We're on example 3 of section 9.2, where we're estimating a population mean. We said there are two types of problems when estimating a population mean. In one type, the last example we worked, they gave us the stats. They gave us the sample size and the sample mean and the sample standard deviation. Notice this problem does not give us that, but they give us the data. So we'll have to enter this data in a list and then continue. So let's do that. This is the amount of ounce of juice in 8 randomly selected juice bottles. So we do know that N equals 8, but we won't have to enter that because we're going to enter the data in a list. So we can remember where you do that, stat edit. And I'm going to clear by highlighting my list number and hitting clear and enter. So I have a nice clean list 1. So I enter this list, 15.2. Encourage you to do the same. Get this practice in. Make the homework go much quicker. Okay, so notice it's saying list 1 number 9. It's waiting for number 9, but I only have 8 values, so I'm done with that. All right, it says what is the best point estimate of the mean amount of juice in all such bottles? Round to 2 decimal places. Well, what is the best point estimate of the mean? X bar, right? The sample mean is the best point estimate of the population mean. X bar is the best point estimate of mu. So do I have X bar? No. Can I get it? Sure. I can go to stat and calc, and it's in list 1. I don't have anything in list 2 that I'm using. I don't have a frequency list. Calculate, and at the top there's my X bar, 15.5375. But it said to 2 decimal places, so that would be 15.54. And what is this? This is in ounces. Okay, that's the best point estimate. But now we're going to construct a confidence interval for the mean amount of juice in all such bottles. Remember, we're using T interval. Right? So stat tests, and remember it was what, number 8? T interval. This time I have data, so I need to highlight that I have data. And it is in list 1, so I'll leave that. You can leave frequency at 1, that'll work just fine. And the confidence level we're supposed to use this time is 90. So it's going to go find that list and do all the calculations for us. Okay, so for T interval, I might note to myself that I put it in list 1 and I put in 90. That way, you know, if you were taking a test, you could easily go back, especially if you're not typing over lists, which is smart to not type over your lists in case you need to go back and check to see that you entered the numbers correctly. If you've got time at the end of the test, that's a good idea, but you need to leave it all in list 1 to do that. Okay, so here's our result. Lower bound, upper bound, this is ounces of juice in the bottles. Notice it returned the X bar. So I actually could have waited and got an X bar right here. That would have been fine. This is the standard deviation. I don't need it for anything, but that is the standard deviation. Ounces of juice, 0.31. And there's that sample size. Okay, let's put our interval down here. It was 15.329 and 15.746 upper bound. Now putting it in our format, I have to put my units in 2 decimal places. So 15.33 ounces, I'll abbreviate ounces, OZ, to 15.75 ounces. See, by putting the units in there, this all has some context to it. It has some meaning, not just a bunch of numbers, but now we know what we're talking about. And our results. We are 90% confident that and I'm going to go right here. The mean amount of juice in all such bottles is between and between what? Well, we said 15.33 ounces and 15.75